does only true inverses, but you have to do this without your calculator. So for instance, the sine curve, and write this down if you weren't here or you just didn't get it. Here's my sine curve. Make a sine curve. So your sine curve starts here and goes like this. So it keeps on going and back up. So here's my sine curve. Now, we always start at the 0 and we go to quadrant 1 because this is 90. This is 180. This is negative 90. This obviously does not pass a horizontal line test, the sine function, right? As soon as it turns over that vertex there, comes over that hump, it does a horizontal line test. So we travel until we hit this peak. And we have to cut it right there. Same thing you did with parabolas. When we said take the decreasing or take the increasing. Same thing. So then we go backwards. We come back here to the negative 90 until it hits. So the only thing we can do is this piece right in here. And when we go from 0 to negative 90, what quadrant are we in? 0 to negative 90. What quadrant are we in? 4. So this is quadrant 4. Remember, this is a continuous curve. 1, 2, 3, 4, 1, 2, 3, 4. So for sine, your restricted domain is from negative pi over 2 to positive pi over 2. Grab one of those sheets, Daniel, please. This is the only part you can use. From negative pi over 2 to positive pi over 2. We said from quadrants 1 and quadrants 4. Quadrant 1, everybody will be positive. Quadrant 4, the sign is negative. So when I get to here and I want an angle, this is what this means, an angle whose sine is and I use an arc, this is a restricted value. I have 2 quadrants in my 4 that sine is positive, 1 and 2, but I can't use 2. I can only use 1 and 4. So I start like this, 1 and 4. Which one is positive, 1 or 4? 1. So I'm not looking down here. So I set up my sign, y over r, and this is an exact value. So my domain is going to come through here and say, what angle is this guy? Only here. I'm in quadrant 1, so what angle is that guy? 30, because it's your special triangle. So 30 is pi over 6. My domain can only go from here to here. And if I'm in the quadrant 4, I have to have a negative angle. Now you can check these on your calculator, because your calculator says, yeah, I can only do restricted functions.
Is the positive 90 degrees included?
Yes, on this one, yes, because you have sine at 90 degrees. Your sine at 90 degrees is 1. Your sine at negative 90 is 1. So therefore, your range is still negative 1 to positive 1. Yeah, it's probably just missing units. Okay, so you can use both of those. Now, what I said you don't have to be responsible for is if I ask you to find the domain of the inverse function, that's this guy. This is the domain of your inverse. This is the range of your inverse. I said, yeah, you have to understand that it works that way. You don't have to graph it. I don't need you to graph that graph. Because if you remember back to Friday and for Thursday, and for those of you that weren't here Thursday, what happens is we have to change your axes. Because your axes go 90, 180, 360, blah, blah, blah. All your angles are here. All your numbers are here. So if we have to interchange them, your angles have to go up here on your y-axis. Your numbers have to go here. So all we really have to do is convert your pi's, like the 3.14. We just have to put numbers by here. So at here, this is like a 3. This is like a 3 over here. And this 1 would be a little bit less than 90. 90 would be over here if this is 1. I didn't ask you to graph it. I need you to know this is what happens to it. If they swap because of this, but I didn't ask you to graph it. Basically, what you have to understand is what quadrants am I looking in? And this is what I want to see. Quadrants 1 and 4 are sign restricted, but I can only use quadrant 1 because it's positive. If it was a negative sign, I would use quadrant 4. Did you get that? Oh, you did. Okay. Make sense? Okay, now tangent, let's just continue with this as a good review. I'm going to do tangent next because tangent is pretty similar. Tangent goes like this. Here's your 90. Here's your negative 90. These have asymptotes here. Tangent goes like this. And then it goes like this again. Tangent is nice. The period is pi. And right in here is the only place I need to worry about. Because here, I fail a horizontal line test. I always pass a vertical, but I fail a horizontal as soon as I go back to these. So all I need is this. So my restricted domain is very, very close to the sign. The only problem with this is, it says you cannot use pi over 2. Grab one of those sheets, please. You cannot use pi over 2 because pi over 2 has no tangent. What do you have there, say? Okay. Pi over 2 has no tangent. And a little bit different here, your range is all real numbers. So when you swap them out, this is going to be the domain of my tangent inverse. This is going to be the range of my tangent inverse. And again, we're dealing with quadrant 1 and 4. This is what we did on Thursday. Inverse. Kind of remember back to when we did the parabolas. And we restricted the legs, or the arms, if you will, because we couldn't fail that horizontal line test. So I would have to tell you if it was increasing or decreasing. The last is cosine. Now cosine works a little different. Same concept, but cosine says this. Here's my 90. Here's my 180. Cosine starts here, and then goes like this. So my cosine curve, if I start in quadrant 1, I can't go backwards. I only can go to quadrant 1, so I would be failing a horizontal, so I'm going to cut it right here. I keep going until I hit this little hump, and I have to cut it here. So from 0 to 90, I'm in quadrant 1. From 90 to 180, I am in quadrant 2. So your cosine says I have a positive in 1, I have a negative in 2. So your restricted domain says 0 to pi. Your range is still negative 1 to positive 1. Your inverse is still swap. This is the domain of my cosine inverse. This is the range of my cosine inverse. And I need you to know the restricted domains and that we swap them, but I don't need you to graph it. I just need you to lay out the quadrants that it falls in. So this guy falls in 1 and 2. That's what I'm looking for on your papers. I realize you could put these in your calculator. Why would I give you something that you could just put in your calculator and get the answer? This is no calculator. And I remember somebody in here asking me on Thursday, do we only use special right triangles? Yeah, those are the only ones you can get the angles to. Your special right triangles and your quadrant angles. Otherwise, yeah, you have to pick up your calculator. But not for these guys. Questions? For those of you that are in here, questions? Okay. This is basically all we really do with your inverses. All we really can do with your inverses. So when we come to this one, I want an angle, an inverse. I want an angle whose sign is 0. So the first thing we do is we say the restricted domain is from negative 90 to positive 90. This is quadrant 1 and quadrant 4. So I'm going to be somewhere from here. That's the only place I could look at. And again, I can include the 90 and the negative 90. So sine is my y value. And this guy's 0. So which one has a sign of 0? At the 0. And if you lay out your number line like this, which we did, your angles have to come in between here. Does a 0 fall in the middle of that? Absolutely. It has to fall between that restricted domain. So while I'll have that up there, let's do this guy. Sine of 1. Still, I'm only restricted to this, negative 90 to positive 90. 1 and 4. So I'm looking for my sine to be 1, my y value. This is the negative 1. So right here, at 90. So my angle has to be 90. If you put this in your calculator, it will say 90. I need to see where your restrictions are. No calc on these. Cosine. Cosine's a little different. Cosine says, here's my cosine curve. My cosine, I'm using 1. Oh, there's my tangent. My cosine says 1 and 2. So my cosine's going from here to here. So I want, when it's a 1, I want the x value or the y value? X. So which one has a 1? Right there, at the 0. My restricted domain is from 0 to pi. You've got to get those restricted domains down pat. If you kind of just draw your curve, you don't have to memorize anything. It makes sense where you're cutting it off. We always use quadrant 1. If you notice, tangent, sine, cosine, positive in 1. Not a lot to remember. So then sine and tangent are negative in 4, and cosine is negative in 2. Really, that's all of you have to memorize. That's what you have to memorize. Everybody's positive in 1. So as soon as I see a positive value, I'm in 1, except for your quadrant angles. Okay. So this guy says I have a tangent. I want an angle whose tangent, so let's just say first it's positive, right? It's positive. So that puts me in quadrant 1 automatically. My restricted domain is from negative 90 to positive 90. But I don't need to worry about that because I'm in quadrant 1 because this is positive. If you unrationalize, it's probably easier. Tangent is y over x. So if you did this, you're going to get your y and your x. Oh, sorry. And your x. If you do Pythagorean's theorem, you'll kind of maybe get down to where this was a 1. You multiplied it by radical 3. This was a radical 3 multiplied by itself. This was a 1. That was multiplied by radical 3. And that would be your 2. So unrationalize this if it's helpful. I find it more helpful to unrationalize it or work it out and then find your one that's your multiple. Give me this angle right here. It's got to be a positive angle. It's got to be from 0 to 90. And this works out to be a 30 degree again. This is your special triangle. Yes?
Why is it not included in the restricted domain?
Because at tangent of 90, it's undefined.
Oh.
So we can't put this one or this one here.
Okay.
If you think about your tangent curve, if you will, curve, it has those asymptotes right there.
Okay.
So we can't go to those asymptotes. But the beauty of tangent is it just kind of shows us, oh, that's a perfect spot for me to be in quadrant 4 to quadrant 1. So let's take this guy, tangent. Tangent is positive here, negative here. So this gives me a negative. Tangent is y over x. So I'll put this a 1. So 1 and 1, your 45 degree angle. Now, here's the thing. It's a 45 degree angle here. But my angles have to run from negative 90 to positive 90. That negative 45 comes right here. I have to name it with a negative angle. I cannot name it with its coterminal positive angle. It's out of my domain. So if you give me 7 pi, what is it? If this was 8 pi over 4, if you gave me 7 pi over 4, that's wrong. It only can go from negative 90 to positive 90. And your calculator will also give you the negative. It has to follow your domain. Make sense? Okay, did you have these also? Alright, so for these guys, same thing. Tangent, find your restriction. You have to go like this. This is easy to do. Go like this. Your tangent is restricted to 1 and 4. Negative 90 to positive 90.
How many is pi over 6? How from 60 is
60? Yeah, it is 60. How many times does 60
yeah,
go with
sorry,
the 180?
sorry.
I know, 60 looks like it should be a 6, right? Yeah, but it's the larger one. So here's my domain, again, for both of these guys. And they're basically both the same. One says a negative, one says a positive. So your reference angle is going to be exactly the same. One's going to be a negative, one's going to be a positive. Make sense? This is probably a good example to see the difference between the positive and the negative. Here's a sign. This is another way to write inverse. You can write inverse like this. You can write it like this. You can write it with a capital. And you can write it with a capital. Those all mean inverses. It means find me an angle whose sine is. So way back, that's what they used to say, an angle whose sine is, and then they got to say arc because the arc is the arc formed by the angle whose sine is. So it became arc sine, arctan, tangent negative 1. This is your true inverse symbol. So sine, this one, since it's positive, what quadrant do I have to be in? First, everybody's positive in quadrant 1. So I don't even care where my restriction is. I know I'm going to be sitting here in 1. So I label my parts. Again, you have to know this special triangles. Those are the only ones I can give you in here. Because otherwise you're going to have to pick up your calc. Yes?
Can't you tell, like, what the angle is, the sine is? Because, like, isn't, like, a smaller angle that has a smaller side? So, you know that sine of 1/2 goes 30.
Yes. Just draw me the triangle. And at this point, the sine of 30, everybody should know it is 1/2, but I don't think everybody does. But just draw me the triangle. I need to see where it's located. And I do get that. So obviously the sine of the radical 3 over 2 has to be the 60. I do, but I just want to see you lay out the parts. So this is your 60-degree angle. Give it to me in radians. Here's a tangent who's negative, 1 and 4. Not counting these guys. Again, unrationalized, it's probably easier. And find your angle. Those are the tricky ones. The negatives for tangent and sine, because your angle has to be negative. It can't be positive. Questions? You guys that missed this, questions? No. Okay, this one. This one they gave you the inverse function. They graphed the inverse function. Now I just kind of want you to get a feel for this. Don't forget, your x and your y-axis swap. Because you're not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the y, it's not that easy. Your angle is on the x, Numbers on the y. So now you're going to swap. So for this angle right here, for this point right here, this is your x value right now because this is your inverse function. This is your x value. So I want, if you think backwards, I want the angle, for this angle, I want its tangent. So what is that angle? Negative pi over 6. What is that angle? Negative 30. So I need a 30-degree triangle. So draw a 30-degree triangle. Just draw one anywhere. What is the tangent for this 30-degree triangle? Y over x. So that's the number I'm going to use. It's on this grid. Is this in the negatives or the positive y's? Negative. So it's going to be negative 1 over radical 3. That's all it's asking you. What would it be? What would that point be if I swapped it around? So when they ask something like this, I have a tangent who's negative radical 3. So again, negative radical 3 means y over x. What is this angle? 60. So it would be pi over 3, but down here, and here, down here, it's negative pi over 3. Negative pi over 3. No, your hypotenuse is always positive. No, this angle, sorry, this angle is negative. The angle, not the hypotenuse, this hypotenuse is 2. Yeah, sorry. Just this angle. And use the graph to help you figure out where's my positive, where's my negative. This is what your inverse functions look like when they're graphed. I don't ask you to graph them because I can't graph them unless I draw out my points. And you can easily take your signs, swap your points, and just plot them in there. If you go based on that pi is around 3, then 90 is like 1.5, 1.6, you'll get a feel for what your axis should look like. But I'm not asking you to do that. And the tangent is nice because your tangent just keeps on going over here. It has a restriction for the negative 90 to the positive 90. So your asymptote now is going to be about 1.5, 1.6 on this side. This will make its own asymptote. Okay, so I think they gave you a cosine. So the same kind of process. Cosine's going from here to here only. So now you can see quadrant 1, they're positive. Quadrant 2, it's negative. And you can figure that out. An angle whose cosine is negative 1, and you can figure that from here. So this is a cosine of 1, this is a cosine of 0, this is a cosine of negative 1. So where am I at? Pi. And your angle now is up here, so that's your positive. You just swap your domain and your range. So your angles now become your y-axis. It's just a little different when you're graphing. I'm not going to ask you to graph it, but to take it off of the graph is just your inverse angles.